Hey everyone, this is going to be a Siko how-to. I have an old starter on my forklift that stopped. It became a stopper. I pulled it out of there. It was pulling a lot of amperage. The battery cables would actually jump when I tried to start it, but no click, no spin, tapping on it didn't help. And I had to figure out why, and I couldn't find a lot of good information online about Inertia style Bendix starters, same as your Model T, your Model A, your old Studebakers, and how to adjust them and set them up. So I had to figure it out, and now I'm teaching you. So I hope you enjoy. So beautiful. So broken. All right, so these are nuts on threads on this starter that adjust in and out. If I adjust them this way, this has a ton of play in it. I assume it's not supposed to, and that you're supposed to stack shims, but if I go the other way too far, this will come out until the starter won't spin. So I think this isn't set up right. I'm sorry, this starter won't spin the gear. The gear will come all the way off of the, what would that be, an Acme Bendix? I'd like to make sure this thing works because it's real hard to get in and out of that forklift. Yeah, check this out. Comes all the way off the threads and spins. That won't help anyone. All right, my seam is toward the open side. Check that out. So on a lot of old starters, you won't have this cone here, and this will be backwards. This piece will actually fit in the transmission and push your gear into the flywheel that way. I've had that on some old Studebakers and some like Ford tractors. And look at this. This tab is not in place, so this can come loose. That's a locking tab. That one's barely on there. That one's not on there at all. It's on a point. So we got to do something about that. But I just wanted to show you. This cutout here is so this doesn't jam up against this. See? Now this has 3 sets of threads. So if I click to the next one, that hits, and it actually sticks there a little bit. It doesn't want to come out. And this comes out with inertia. So it's important that it doesn't stick there. There we go. So it's little details like that when you're rebuilding something that nobody taught me that. I just have to figure it out. And then I need to bend that tab in. I don't want this bolt any tighter, so I'm just going to fold it over that corner on both sides. Now I'm working out the number of machine bushings I need. I went to the hardware store. I bought a couple of thicknesses so I can shim it however it needs to be. All right. Now this spring has no tension in it right now, and it can't. You don't want it to. Also, they have different direction springs based on the direction of the starter, so you have to pay attention. When your starter, let's see, starter's going to spin, yeah, this way, forcing this gear out. And what's going to happen is this spring is to absorb the impact of this suddenly starting the engine. So it's actually going to tighten. You want this spring to tighten down onto this shaft in the middle when it hits. You don't want it to expand because that'll ruin the spring. I mean, that's the only limit of how much it can expand. It can expand way too much and ruin it. So you have to make sure to get the correct direction of spring. So all this does is absorb that hit. So it should be in here with a little tiny bit of play. These bolts should be tight. They should be staked in, but it's not. Then this spring is just to keep it from chattering outward when the car is driving. Yeah. All right, let's get this in there and figure out how many shims we need. Make sure all this stuff is just clean and dry, but I did just put a tiny, tiny dab of lithium grease on the bushing, and I'm gonna do the same on this side. Definitely don't want anything on there. This main field screw that connects it literally to your positive battery cable through the starter solenoid was loose. So that could be my whole problem right there, because when I pulled it off, I hooked a jumper cable to it and zing, and I even tested it through the solenoid, zing. It's like, all right, I'll take it apart and clean everything. I figured it was just a dead contact or a dirty contact on the commutator. But, nope, it is, that was loose. That's probably the problem. Look how black that screw got. That is heat. It's actually blue from heat. All right, so not only was this screw just barely snug, I'm cleaning up the brushes. Which one is it? Look at this. That brush, oh, give me some focus here. That brush is loose, which means this connector is loose. So I'm gonna lose power to an entire field inside of this thing. That could be my problem too. Both of those combined are definitely a problem. So now that this side's done, I'll get that tight, get this side done. I'm almost done cleaning up the brushes. I just put some emery cloth around a socket about the same diameter as the commutator on the armature, and I spun it around in there a little bit. And then some of these had some worn edges, and I just barely touched them with a file, just scraped off that cruft that had built up. But I think this thing will run great. So these carbon brushes ride on this, and what it does is there's basically 2 positive and 2 negative, and they're getting their juice for the field. These are supplying the power to the field, these electromagnets there and there. And what it does is the motor, you put power to it and it turns just that much, that many degrees, 360 divided by the number of contacts on this. And those brushes end up on the next contact, which reverses the polarity of the field. So the motor turns a little more. And every time, let me put that in and spin it and show you. Every time it turns, it reverses the polarity, so it zings up to speed. So that is how a DC motor works. AC motors are totally different. I have a lot of random tools that I almost never use, including these guys. And here's why I have 2 of these. If you look at these screwdrivers, this flat blade is vertical and that one's horizontal. When I'm getting down into a spot like this, I can't put the horizontal one in there, in this screw, but I can't put the vertical one. Well, vice versa on that one. So I just had to use both of these to tighten those, or I was gonna have to pull the brushes out to do it. Hey, guess what? That one was super loose. None of the other 3 were very tight at all. So they're all in there good and firm now. Maybe I could have, well, no, I couldn't have got at the screws. Well, yeah, I probably could have. I'm thinking I may need to loosen them and move the angle slightly, at least the one that was loose, so that it's not angled on the armature a little bit. All right, let me show you what I was just talking about. See how that's sitting nice and flat there? And that one, and that one. But look at the one that was loose. There's a big gap at the bottom, because when I tightened it down, it rotated slightly. So I need to crack that back loose, hold my finger in there to make sure it's flat against there, so we don't have that gap at the bottom. Maybe it'd be easier to see from the other side. Oh yeah, you can see right through it. Big gap right at the bottom. Ta-da! So I have the solenoid and this starter hooked to the battery. So if I power the solenoid like the ignition switch would, sorry about the shade, which I'm gonna do with my power probe, which is also hooked here to power and ground, it should spin just great. Check that out. This engages just like it should. It even returns, which is fancy. Look at that. That is perfect. There's those shims I added. I took one of the old ones out, added 2 new ones to get my thickness right. And I'm just gonna run this for a minute. It's really shaky on the floor, but it's running away from me. That's sweet. All right, it's nice and smooth. Let's get it back into old Clark here. Another set of overkill battery cables for this garbage antique Clark forklift. Every time I work on it, I make something amazing. So right now, my favorite amazing battery cables. These are good for a Cummins truck or a Duramax, whatever. These are good for a big, heavy diesel truck. But yeah, look at that. Brand new cables for a rebuilt starter. Let's see if it cranks. Oh man, that's never cranked that good. Sweet.